Here we are in the last section of Chapter 8 that is on area. We're on 8.7 surface area, and we're going to be looking at the surface areas of three-dimensional objects such as prisms, cylinders, pyramids, and cones. Just some terminology related to these things. In a prism or a cylinder, you are looking at a three-dimensional shape that has two parallel and congruent bases. The bases usually are the top and the bottom of the shape, but technically the bases are the two polygons here that are opposite each other and parallel to each other, right here and right here. And then the rest of the side is called the lateral side. Lateral, remember, means to the side. So a lateral face is the rectangle that is on the side here. And in a prism, the lateral faces will always be rectangles or parallelograms. All right, so the area of that would be made up of the base polygons and then the rectangles or parallelograms around the side. Cylinders are similar. Cylinders are the same idea, only they are circular for their bases, like a can of soup. And then the lateral face would just be the side that goes around like the label of a soup can. And when we're thinking about the area formulas, we're going to pretty much bypass a formula. If you look these up in a book, you probably will find a specific formula for the entire shape. We're just going to break it down just logically. When you're trying to find the total surface area of a prism or cylinder, we're going to add up the base areas. So whether they're circles or whether they're hexagons, we're going to add those up. And then we're going to add up their lateral areas on the sides, so the side area, and then get a grand total for all of the areas, and then that will be the total surface area. When we're looking at a pyramid or a cone, we are looking at the object that comes to a point called the vertex, usually on the top of the shape. So within the pyramid, we have these triangular lateral faces. It's right here. So the lateral faces of a pyramid will always be triangles, and a pyramid has something called a slant height, and that is the perpendicular segment from the vertex to the base, and it's always going to be perpendicular 90 degrees, and this piece right here, again, is called the slant height. So it's not the actual height of the pyramid, but kind of the slanted height of the pyramid. The pyramid is going to have an actual height that we are going to need to consider here. So the actual height is if you draw a line straight down from the top of the pyramid, from the vertex to the base, and that is going to be the pyramid's actual height. So there's a slant height, and then there's a height of the pyramid. And the same thing is sort of true in a cone. A cone, of course, has a circular base, and that circular base is going to have a radius, right? And then this right here is also the slant height of the cone. So this distance from the vertex down here, so again, vertex, and down to the base. And we use the letter L for that. I'm just going to write a cursive L. And again, that is the slant height. And so we're going to use that when we are talking about the lateral area. And then just like a pyramid, you have a height that is perpendicular from the vertex down to the base. So that is the height right there. So the slant height's kind of the slanted, sideways sort of height. The regular height is perpendicular to the base. All right, so again, the diagram here shows the base. So, of course, a pyramid and a cone have a base. If it's a pyramid, then it's going to be a polygon base, like this is a pentagon. And if it is a cone, it's going to have a circular base. So on a pyramid or cone, we use the letter L to represent the slant height. And the slant height is the height of the lateral face. So if you took that lateral face off and measured just the height of that, that would be called a slant height. So again, we're just going to come up with a surface area strategy for these, which is basically just find the area of the base, then find all the lateral areas, and then total them all up, and we're going to get the total surface area.